Alrighty, well this is it. Radical Equations Part 2. Welcome back. I've got just a humdinger here of an example that we're going to try to work through. And this one here has a bit more of a mess going on because I got two radicals. So it's kind of like, alright, step one was supposed to be isolate the radical. Which one? You know, it sounds good, but I got two here. So here's kind of my thought. Whenever I run into two radicals, you pick one, and I try to pick the uglier one. This one looks like it's uglier. So what I'm going to do is I'm going to pick this one and isolate it. So we're going to try to leave this guy alone, and then we're going to move everything else over to the other side. So I'm taking 5 and subtracting it from both sides. Okay, so that's isolating the uglier radical. Now what I got to do, we're talking square roots here, so I'm going to square both sides, right? That's how we get rid of the radical. The nice side is actually the right side, because the square root of something, and you're squaring it, just means whatever's inside the radical is left alone. Here, you got to kind of do the old write it all out, because it's actually going to be a bigger mess. Don't try any shortcuts on this. This is where most students make the mistakes, is they're too lazy to write it out. You got this whole thing squared, which means times itself. So you have to FOIL the mess out. You have to go 2 times 2 is 4. 2 times the square root of 3x is a positive 2 times the square root of 3x. And then here you got the square root of 3x times 2, so that's positive 2 times the square root of 3x. And then we've got the square root of 3x times the square root of 3x, which would be positive 3x, equals 5x plus 4. Okay, so you go, well, that was nice, but I still have these radicals here. Actually, let's simplify it before we get too carried away. Yes, we do have these radicals, but at least we can combine them because they are like radicals. So that's going to be 2 and 2, so that's 4 of them. Okay, so that's good. And then we got plus 3x's equals 5x's plus 4. Now here's what I got to do. I have to isolate this radical now. So it means I got to move everything else to the other side. So I'm going to take the 4 and subtract it from both sides. Oh, that's nice. That makes life a little better that there's a 4 on both sides. So let's take away 3x's. So that'll leave me with 2x's on the right side. And then here I've got 4 times the square root of 3x. Okay, now I've kind of isolated the radical. There's a 4 in front, but I don't want to get into fractions, so I don't want to divide by it. I'm just going to leave it. And now what I'm going to do is I'm going to square both sides, and that's going to get rid of the radical. Now, let's see here. I think I've run out of room, so what I'm going to do is I'm going to get rid of the stuff in the middle here, because I kind of want to hang on to the top equation still. And I want to hang on to the stuff in the bottom. So I'll see if I can delete that out of there. Oh, and this little fragment. Let's get rid of that. All right, so I think we're back in business. So now I'm going to continue my work up here. This is my continuation. So here, be very careful when you're squaring this out. You're getting rid of the radical. That's great. So you're going to have 3x. But you also, don't forget, you're squaring that 4. It's actually going to become a 16 times 3x. And then on the other side, you've got a 4x squared. All right, so now what am I going to do? Well, I've got 48x's equals 4x squared. So to solve this, I'm going to bring the 48x's to the right side. Okay, and I've got this, what is actually called a quadratic equation. Not that that's that important yet. But I'm going to make life a little easier because I can see I divide everything by 4. And then I don't have quite as many numbers to worry about. So I got x squared, and 4 divides into this thing 12 times. And here's how we're going to solve it. We're going to take out a common factor of x. Okay, so that means x times x minus 12. So you see how x times x is still x squared, and x times negative 12 is negative 12x. So now that it's factored, I believe I'm going to write them over here. I have what seem to be 2 solutions. If I make x 0, 0 times this stuff would make the right side equal 0 on the left. So 0 looks like a solution. And the other solution looks like 12. If I plug 12 in, 12 take away 12 turns that stuff into 0, and 0 times anything will make it equal 0. So I'm using the 0 property there to come up with what look to be solutions. All right, let's clear a little space, and what's really important now is I got to make sure this stuff actually works. So let's clear this out of here. Okay, and some more fragments to get rid of here. Let's get rid of this too. It'll look neater. All right, I'm all set to do my check. Really important that you check this stuff. Okay, so let's check 0 first. Okay, if I plug in 0, I got 7 plus the square root of 3 times 0, which will just be 0. Is that going to equal the square root of, and I can put 0 in here, so that would turn out to be a 4 plus 5. So what are we getting here? We're getting 7. We're getting 2 plus 5. Hey, that's 7 as well. Well, what do you know? This guy works. Perfect. Okay, let's check if 12 works. Yeah. All right, bigger numbers here. Bigger numbers, but that's okay. So we got 7 plus the square root of 3 times 12, so that's 36. Actually, let's just finish the left side here while we're at it. Looks like we're coming up with 13. Let's see what we get on the right side. So we got 5 times, here's where I'm looking at. 5 times 12, so that's 60. 60 plus 4 is 64. And I'm square rooting all that, and then I'm adding 5. Now, the square root of 64 is 8. Well, look at this. We're getting 13 as well. So they're both checked out and working solutions. So very nice indeed. But with that, I am done. And I think I'm done for this unit now. So we'll catch you in the next chapter.